Hello class 9. Today we are going to start with chapter 7, reflection of light. Suppose if we take a reflecting surface and there are some parallel beam of light which falls on the surface. And since the surface will be reflecting, so the lights which will be incident on the surface will bounce back this way. So when the light bounces back or returns back into the same medium, then we call this phenomenon as reflection. So simply, reflection can be defined as the return of light into the same medium after striking a surface is called reflection. So here you can see the red beam of light after striking the surface bounces back to the same medium. So this phenomenon is the phenomenon of reflection. Now there are two types of reflections. Firstly, regular reflection. Suppose if you take a plain and smooth surface, okay, and then the parallel beam of light falls on the surface, just like the previous case. Then again, the reflected rays will be the reflected rays on a smooth and polished surface. Over here, this plane mirror, as you all know, it's very smooth and it will be polished such that the rays which will reflect back will be parallel. Okay, so these kind of rays, if we look at the reflected rays from this particular point over here, then we'll see that the reflection is coming directly from this point. Okay, so the reflected rays can only be viewed or only can be observed from a particular direction. Okay, so this happens because in a smooth or a polished surface, the light beam will be reflected perfectly. So thus it's called a regular reflection. Next we have another type of reflection which is called as irregular reflection, or sometimes also called as diffused reflection. This irregular reflection takes place on a rough surface which is irregular. Now this surface, when the light falls on this kind of surface, the incident ray after falling on the surface will be reflected randomly in all possible directions. Okay, so the regular beam of light which falls, the parallel beam of light which falls on the irregular surface or rough surface, then reflects back in random way. So this reflection will be diffused. Diffused means the reflected rays will not be parallel, but this can be these rays will be reflected in all possible directions. So these rays can be viewed or observed from all the directions. So simply we can say that it is because of this diffused light that we can see the various objects all around us. So it is the diffused light obtained by reflection from various uneven surfaces which enables to see the objects around us. So that's why when there is no sunlight during daytime, even if if it's a cloudy day and the sun is not in the sky clearly seen, even though we can see the things around us, it's because of the diffused reflection from irregular and rough surfaces. The lights gets reflected in diffused manner. So these lights will be seen from every possible direction, and this is the importance of irregular reflection. So if anyone asks you what is the importance of irregular reflection or diffused reflection, then you can say that because of this diffused reflection only we can see the things around us Okay, if it would be only a regular reflection, then in that case only the lights would be seen from a particular point or from a particular direction. Okay, so irregular reflection or diffuse reflection has this importance that it can be, the light makes us see the things around us properly. Next one will be the terms that we'll be using in this chapter. So we'll first use this ray AO. This AO is the light which falls on the surface MM1. So MM1 over here is the mirror, and the light is falling on the mirror at point O. So this line is called the incident ray. And since it is falling on the surface at the point O, so point O will be called as the point of incidence. And this is the line which is perpendicular to the surface, and the perpendicular line is normally called as normal. Okay, so this is called the normal to the line to the surface MM dash. Okay, and this beam of light which after striking at point O gets reflected back, so it's called the reflected ray. So OB is the reflected ray. This I is the angle of incidence, and this R is the angle of reflection. So angle of reflection is between the reflected ray and the normal. Okay, angle of incidence is formed between the incident ray and the normal. Okay, so let's see the definitions. Incident ray, the light ray striking a reflecting surface, is called the incident ray. So over here AO is the incident ray. Next, the point of incidence, the point at which the incident ray strikes the reflecting surface. So this point O is considered as the point of incidence. Over here the incident ray is striking at the surface, so point O becomes the point of incidence. Next, reflected ray, the light ray obtained after reflection from the surface in the same medium. That means this ray OB, which is reflected back, and it is reflected at the same medium where the incident ray was traveling at first. Okay, so the light ray obtained after reflection from the surface in the same medium becomes the reflected ray. Normal, the perpendicular drawn to the surface at the point of incidence. So this is the normal, and it is perpendicular to the surface. All right. Then we have angle of incidence. Angle of incidence, it is represented by small I over here. Okay, the angle made by the incident ray and the normal. Over here, this small I represents the angle of incidence, and this is the angle of reflection. So it is the angle made by the reflected ray and the normal. Now this is very important, plane of incidence, the plane containing the incident ray and the normal. So over here, if you see, if we pass a plane, something like this, okay, through the incident ray and the normal, then it's called the, this plane is called the plane of incidence. All right, and the plane of reflection will be the plane containing the reflected ray and the normal. That will be, if you pass a plane through the normal and the reflected ray, then that plane will be called as the plane of reflection. So in this figure you can see that plane of incidence and plane of reflection are the same plane. This one, okay, it's actually a 3D picture, you should imagine it this way. So it's a plane in which the incident ray, the normal and the reflected ray all are lying on the same plane. All right. Next we'll move on to the laws of reflection. The first law of reflection says the angle of incidence is equal to the angle of reflection. So again over here it is angle I is equal to angle R. This cannot be seen over here. Its angle I is equal to angle R. So again, referring back to the same figure, you can see this angle of incidence and the angle of reflection, both are of equal magnitude. So angle of incidence, angle I, will be equal to angle R. Next will be the second law of reflection, which states that the incident ray, the reflected ray and the normal at the point of incidence all lie in the same plane. So over here, this is the angle of incidence, sorry, this is the incident ray, this is the normal, and this is the reflected ray. They all lie at the same plane, means here this is the plane in which the incident ray, the normal and the reflected ray all are lying. Okay, so the second law says the incident ray, the reflected ray and the normal at the point of incidence all lie in the same plane. So this is the second law and the law of reflection. Okay, so with this we come to an end of our video. All right, we'll discuss in the next class more about the reflection and the formation of images. All right, thank you.